Hello and welcome back to my channel. If you are new to this channel, my name is Frank Zhu and I'm a college professor teaching sociology, history and philosophy. I'm also an award-winning landscape photographer. Today, I'm going to talk about history. More specifically, as you have seen from the title of this video, I'm going to talk about the scientific revolution in history. As a history professor and the author of a history book, I feel sorry that I haven't devoted enough time to the subject of history on this channel. But I will create more videos about various historical topics in the future. Please subscribe if you are interested. But before I get started, let me pose a couple of science-related questions to you. Number one, why do we see the sunrise in the east every morning and the sunset in the west every evening? Does it mean that the sun is moving across the sky every day? Number two, why are there 365 days in a year in our calendar? Is it a correct number? 3. Why are there 4 seasons? I'm sure you have enough science knowledge to answer those questions. But in ancient times, there was no science as we understand it today. In fact, up until 400 years ago, nobody had the correct answers. So, how did people in the past explain those natural phenomena? What happened to change their perceptions of the natural world and enable them to come up with the correct explanations as we have today? Well, that's what we are going to discover in this video. For the sake of time, in today's video, I will only focus on the major discoveries in one field of science, that is, astronomy. I will make more videos in the future talking about other major discoveries during the scientific revolution. When we talk about the scientific revolution, we are talking about a time period of nearly 200 years up until the mid-18th century in Europe. 200 years may seem a long time, but it is a time period in which big fundamental changes were happening at a rate never seen before. That's why we use the term revolution to describe those changes. The significance of it is that the revolution ultimately challenged the religious conceptions and beliefs about the nature of the external world, which had dominated people's thinking for many centuries. As a result of new discoveries, the notion of human beings themselves and the universe was totally changed. A new social order was created, which was dynamic, rational, and materialistic. Together with the Enlightenment movement, which followed, the scientific revolution contributed to making Europe the dominant power of the globe. In Western history, the scientific revolution forms the dividing line between the medieval times and the early modern times. The scientific revolution had its roots in the late Middle Ages. For those of you who are not familiar with European history, the term Middle Ages refers to the time period since the fall of the Roman Empire in the 5th century until the Renaissance of the 15th century. I will talk about those historical periods in my future videos. By that time, though religious thinking still dominated the world, and many people still stuck to the notion that the universe was the creation of God, some people had come to recognize that many natural phenomena could be explained in new ways other than by the Bible or other religious doctrines. This new recognition was largely driven by new discoveries and new inventions. For example, some crucial progress in mathematics and physics had been made. In addition, the printing, which was invented by the Chinese but perfected by the Westerners during the late Renaissance period, made it possible for scientists to exchange ideas and information faster than ever. Of course, Aristotelian physics still dominated European scientific thinking. By the way, Aristotle was one of the greatest Greek philosophers in the 4th century BCE. According to him, the world was comprised of 4 basic elements: air, earth, fire, and water. All matter was arranged in a hierarchy according to the quality of its substance. For example, earth was the heaviest and the basest of the elements, and therefore it was at the center of the universe. His theory also held that objects of similar substance tended to come close to each other. For example, he claimed a stone fell to the ground because the stone and the ground were similar in substance. Likewise, smoke rose away from the earth because it was primarily air, and therefore the smoke wished to be closer to air and farther away from earth and water. That's why smoke would go up and never come down. Furthermore, according to him, objects on the earth only moved as long as they were pushed, which was why they stopped moving once we stopped pushing them. The same was true with the heavenly bodies, like the sun. They moved only because of the action of the prime mover. In other words, it was a God who was continuing pushing the heavenly bodies. Aristotelian theory was basically a geocentric model. According to this theory, the earth was stationary and motionless at the center of the universe. The sun and the moon and other heavenly bodies all evolved around the earth in perfect circular paths. His theory fit very well with the church, and it was naturally promoted by the church. As a result, Aristotelian theory dominated human thinking about the natural world. However, as discoveries were made and as more and more data were collected, some astronomers began to see the contradictions and awkwardness of this theory. For example, explorers and voyagers who traveled to the New World brought back large amounts of evidence about nature and geography that could not be explained by the old theory. The need for a new theory to explain observational data thus came to the focus of attention. It is against this background that changes began to occur. The revolution first took place in astronomy, and it should be easy to understand why, because it was a field in which people could observe and analyze in a relatively easy way. For example, you can use your naked eyes to track the movements of the sun and the moon without using sophisticated equipment. One of the first people who made new discoveries was a man by the name Nicholas Copernicus, who has since been viewed as the Columbus of the scientific revolution. Copernicus was a well-known Polish mathematician and astronomer. His achievements drew the attention of the Catholic Church, which at this time was worrying about the errors of the Julian calendar. According to the Julian calendar, there were 365.25 days a year, but the actual solar year is slightly less. As a result, the Julian calendar year was continuously drifting away from the actual seasons, which caused the dates of equinoxes and solstices to shift over time. This created a practical problem for the Catholic Church, making it difficult to calculate the date of Easter, because the Church determined the date of Easter based on the spring equinox. Copernicus was therefore chosen to fix the problem. After many years of research and observations, Copernicus developed a brand new model, which became known as the Heliocentric theory. According to this truly revolutionary theory, the Sun was at the center of the universe, not the Earth. The Earth was merely one of the planets moving around the solar center. Besides, not only was the Earth moving around the Sun, it was also rotating on its axis daily, which was why we saw the sunrise in the morning and the sunset in the evening. He also discovered that the reason why there are 4 seasons is because the Earth's rotating axis is tilted with respect to its orbital plane. Throughout the year, different parts of the Earth receive the sun's most direct rays. When you receive the most direct sun rays, it is summer. Some people mistakenly believe that the 4 seasons are caused by the Earth's distance from the Sun. They assume that when the Earth is far away from the Sun, we receive less sunshine and therefore we enter the winter. The truth is that the difference in distance is very small, and that the amount of sunshine we receive only changes very slightly. With this new model, Copernicus could explain the errors of the Julian calendar. In 1514, Copernicus shared his theory with friends in a handwritten book. However, the new heliocentric model was obviously a challenge to the prevailing geocentric theory, which had been advocated by the Church. Knowing that the book would enrage the powerful religious world, Copernicus did not publish it until his last moments. It was in 1543, the year of his death, the book, which was titled On the Revolutions of the Heavenly Spheres, was finally published. Although it was praised by some astronomers who valued Copernicus's precise calculations, the book was condemned by the religious world and was eventually placed on the list of forbidden books. In spite of the criticism, in 1582, several decades after the book's publication, Pope Gregory XIII instituted a new calendar called the Gregorian calendar. It is the calendar that has been used in most parts of the world until nowadays. Later on, Copernicus' theory was further developed by the German astronomer Kepler. Kepler offered a much more detailed and exact account of the universe. He described in detail the motion of planets around the Sun. For some time, the new findings by Copernicus and Kepler were only known to the intellectual world. Neither the Church nor the scientific world was willing to make it public. Thus, the conflicts continued rather quietly. It was Galileo, an Italian astronomer, who not only proved the new heliocentric theory, but also broke the silence and made it known to the general public. Galileo did this by using cutting-edge technology of the time, a telescope. Through the lenses, he proved that Copernicus' heliocentric theory was correct. However, what made Galileo outstanding was that he published what he found in a language that was understood by a general audience, not for university scholars, because he was using Italian rather than Latin. For the Church, which had remained quiet until now, Galileo's action was the last straw. In 1633, Galileo was tried by the Roman authorities and found guilty for having taught his doctrines against the orders of the Church. Galileo was forced to recant his scientific beliefs. By the way, in 1992, 3 centuries and a half later, Pope John Paul II officially and publicly said it was a sad misunderstanding. Galileo was more than an astronomer. He was also a physicist. Perhaps the best-known physical principle that he established is that weight does not determine the speed at which an object falls. To put it another way, disregarding factors such as air resistance, a soccer ball and a bowling ball would fall at the same speed to the ground. It is said that Galileo climbed up the Leaning Tower of Pisa to drop balls of different masses from up there in order to demonstrate and prove this principle. Well, I think I should stop now because this video is already too long. I know I haven't talked about other very important discoveries and scientists, such as Isaac Newton. But as I said at the beginning, I'll leave them for the future videos. Thank you for watching, and I will see you in the next video.